Alrighty, so this lesson, our plan is to recognize this function, y equals the square root of x, which is the same as y equals x to the power of a half. So if we go back just a step and think about y equals x to the half, we'll come over here. Whoops. We'll come over here. If y equals x to the half, if I square both sides, that's the same as saying y squared is equal to x. So what we're saying is that's like a parabola around my horizontal axis. Now, if y, that is the graph, that's the graph of y squared is equal to x. So if I get y on its own, y is equal to the square root of x, I would get plus or minus. Remember, we take the square root, we get plus or minus. So in this case, if I've just got if I want to sketch just y equals the positive square root of x, let's grab our eraser, it means it's just the positive section. So it's just that part of the parabola, okay? So that's what the graph of y equals root x looks like. So let's go into our graph here, get that square root of x. If I put x equal to 1, y is equal to 1, so we'll call that 1. It looks something like that. So that's the y equals root x function, okay? No asymptotes in this case. It starts at the origin 0, 0, and we've just got the top half of a parabola, all right? So what happens here with example 6? Y equals the square root of negative x. Now we're going to talk about some reflections and translations later on in our topics, but think about what the negative sign in there means, okay? If we have a look here, let's go back a bit. It says the domain. We've spoken about the domain. Well, if we're going to take the square root of something, it has to be the square root of a positive number. That's why we need x is greater than or equal to 0, okay? So there's the domain. That's why we're only defined over this section here. So if y is equal to the square root of negative x, well, x is going to be less than or equal to negative, less than or equal to 0, negative 0, less than or equal to 0, because if I put a negative number in there, the negative makes it positive. So that negative side inside the bracket, all it does is it flips it around this way. Okay, it's just part of my graph, part of my square root function, but it's just flipped in a different direction. Okay, we say that it's rotated about the y-axis. There's my y-axis, and it's spun about the y-axis. Similarly, if we think about y equals square root of x, well, if my the negative square root of x, there's my original graph. There's y equals root x. And if I take the negative of that, well, everything just becomes on the bottom, doesn't it? Instead of being up here at positive 1, it's down here at negative 1. So my negative root x graph is that one. Okay, and we call that a rotation about the x-axis. And we'll talk more about that stuff later on, but it's nice to get used to that terminology. So that's my square root of x function. Okay, it's just half of a parabola. It could rotate, it could be flipped upside down, it could be pointed back to the opposite direction, just depends on the question. Let's have a look at a few more. Square root of x plus 1. So what we want to do here, let's think about what our graph is doing here. What does, if I sketch the graph of x plus 1 all squared, what does that look like? We know x squared starts at the origin. X plus 1 all squared actually shifts it back here to negative 1, doesn't it? And it looks like that. Okay, so it's similar here. Another way to think of it is we need, okay, so I need x plus 1 to be greater than or equal to 0, because I can only get the square root of a negative number, which means x has got to be greater than or equal to negative 1. So there's my domain. Okay, so the domain is going to be from negative 1 to infinity. So similarly, let's go back to negative 1, and my graph is going to be like that. We've got a y-intercept there, obviously. If I put x equal to 0, I'll just change the color. So the y-intercept, put x equal to 0, I get y is equal to the square root of 0 plus 1, which is just equal to 1, which is there. That one's -1. So I guess we know that the graph has shifted back 1 unit for 2 reasons. Our knowledge of our graph, of our parabola, so there's my new domain, okay. Also, if we just check x plus 1 has to be greater than or equal to 0, that means x has got to be greater than or equal to -1, so we'll start at -1. Now that we've spoken about range as well, we can see that the range of this graph, so let's put the range in. The range is going to be 0 inclusive, round bracket, to infinity. All right. So even though some of these questions won't be asking you for domain and range, because remember we've changed order a little bit, let's put them in. Example 9. Okay, x minus 1 within. So let's do it one way. I need x minus 1 to be greater than or equal to 0. Otherwise, I can't work it out. That means x has got to be greater than or equal to 1. There's the domain. Which means the whole graph is shifted across to the right 1 unit. I'll just do a quick sketch like that. Let's have a think now about plus 1. What was the plus 1 been doing? It's been moving everything up 1 unit. X squared plus 1 is like that. So let's shift the whole thing up 1 unit. So it goes to there. And our graph just comes through like that. So that's the point at 1, 1. What does that domain look like? Oh, sorry, that range. So let's go, well, domain's in blue. So there's the domain of my graph. X is greater than or equal to 1. The range of my graph, minimum y value up to the maximum y value. So let's come across in here and let's write down the range is from 0, oops, not 0, 1, up to infinity, or positive infinity, optional. Okay, so again, remember domain x, range y. 1 unit up, 1 unit right, and it doesn't hurt to actually perhaps write that. Let's go to our last question. It looks a little bit more involved. So, what have we got? Let's think about the domain. I need minus x minus 1 to be greater than or equal to 0. So, let's go this way. Let's go minus x plus 1 has to be greater than or equal to 0. Now, I guess we can take the 1 across. Minus x is greater than or equal to -1. Now, if I divide by a negative number, my inequality changes the sign. So x less than or equal to +1. So what does that mean my domain is? It's got to be less than or equal to 1. So my domain is going to be 1 back to infinity, negative infinity. So I know that's where my graph is. So it's from +1. But, so in black domain, my domain is this way. So that's the direction my graph's going to have. I'm moving 1 up. So let's shift the whole graph up 1 unit. So let's go to here. And given my domain is back in this direction, that's the shape my graph's going to have. My parabola is going to go back that way. And if I check that, let's put x equal to 0. If x is equal to 0, y is equal to the square root of negative 0 minus 1 plus 1, which is just 1 plus 1, which equals 2. So that matches off to that point. Okay, that point here, 1, 1 again. So this is a bit tricky. In here, well, I guess not really. We're still 1 across, we're still 1 up, but the negative sign, remember from our previous example, has the domain being all negative values, so it goes that way. It's got a slightly different shape. If you're not confident with that, just get your intercept first. Get your starting point, get your intercept, and then it gives you an idea of which way the graph has to go. So again, we've already said what our domain is, from negative infinity to 1. My range is going up there. So clearly the range is from, what's that? 1 to infinity. All right. So there's the third of my graphs. My square root function, again, every time I go to do a question, it's just a quick sketch, something like that. Not very nice one, that one. So let's get a bit more parabolic. Let's get that done. And again, moves it to the right, moves it up, and it has the same impact each time. The little A at the front, a bit fatter, a bit skinnier. All right. Sorry, boys, just got caught watching the cricket there, the test against South Africa. Again, questions 1 and 2. It's going to be the same shifting. It's going to be a -1, a +1, move it up, reflect it. You've just got to get used to starting with the basic shape and then making a change. You've got to make a change.